student friends. In continuation with the forging process, we will see the heading. Now you can see in the figure heading of a nail using open dies. Now you can see nail means काय खिळे. Nails, these are used for the construction purposes. This is the die and this is the punch, and this die is used to hold the workpiece, and this punch will apply the compressive force so that localized deformation of this head will takes place. And this is the manufacturing of nail by using a heading operation. This is the cold heading process, means material is not heated as a cross section area is less, as well as ductility of material is more, heating is not required. In the second case, round head is formed by using a punch. Now in this first case, the punch is a flat, and here semicircular die cavity you have to machine to this punch, so that by the application of the force by the punch on this head, it will get deformed, and round head you will get to this nail. Now these are the common shapes for the head of the screw. This is the C and D portion. These are the common heads used for making the screws. Now last figure, 5 number figure, is the carriage bolt, and this is formed by using the punch. Here again punch is required to have some design, and carriage bolt head is manufactured by using this type of punch design. Now next operation is the fullering. Fullering operation is again the localized deformation of the workpiece, so that we can reduce its cross section and we can increase its length. This is the fullering operation. And opposite to the fullering is the edging operation. Means in case of fullering, the compressive force is applied along the y-axis or about vertical axis, and in case of edging, the compressive force is applied along the x-axis or around the horizontal axis. This is the edging operation. Next is the schematic of rotary swedging process. This is the top view of the dies. This is cut section or side view cut section of the dies. Now you can see this is the workpiece. At the center you can see this is the workpiece, and swedging dies. In the swedging dies, the workpiece is compressed. Swedging means to reduce its diameter and proportionately increase its length. Now you can see here this is the finished part. At this location swedging has taken place, at this location also swedging operation has taken place, and each time you will achieve certain amount of reduction, and this is the rotary swedging process. These are the rollers. Rollers are used to give support to this upper die and lower die. Now here, rather than using the word upper die and lower die, we will use the swedging dies, because the dies are in the rotary condition, and the complete process is in the rotary condition, and these rollers are applying the compressive force on these dies. This is schematic of rotary swedging process. Now these are some of the forged products. Forging has a wide application in the mechanical industry. Many components are produced by the forging. This is the camshaft. These are the cams. These are mounted on this one shaft. Crane hooks are there. Eye bolt is there. Many, again Allen key is there. This is the key. Again many products like knobs for controlling of the wall, for controlling of the flow. Various knobs are required in the industry. They are also made by using this forging process. Circular disc also can be made by the forging process. These are the spanners. This is connecting rod. These are hooks. That are also made by the forging operation. Hot forging is main technology to fabricate the connecting rod. This is the connecting rod of the IC engine. Due to complex geometry, connecting rod cannot be produced in one blow. Near about 7 to 8 blows are required. You can see here the blows. This is the primary shape given by the rolling. From this point, blows of the hammer are required. Near about 6 to 7 blows of the hammer are required, as connecting rod has a complex geometry. Several impressions initially we have to make to this dies. Basically, connecting rod forging can be executed in one at a time or two at a time version. Means at a time only one connecting rod we can manufacture, or two we can manufacture. One multi-step One multi-step, one at a time forging variant which is often applied in the industry is shown in figure. This is one step, one at a time. This is the forging setup for the connecting rod of the IC engine. Means at a time only one forging, only one connecting rod is made. Before forging, billet is heated to the required temperature and then transported to the die. Forging dies consist of fullering, aging, blocking and finishing impressions. As it is seen, most intensive material flow takes place in the blocking impression D number die. Means in this die most extensive material deformation takes place. In the here also you can see most intensive material flow takes place in the blocking impression. You can see here means maximum deformation is achieved in D type or D step and minimum flow occurs in the impression. This last is the impression die in which only trimming takes place and final finish is given to the connecting rod. After forging, trimming in a separate die is performed. Process steps are given in the figure. You can see here this is the raw material and this is the finished product, and we have to follow these steps by using the forging operation. This is the die cavity, this is the upper die and this is the lower die, in which we have to place this component by heating it above the recrystallization temperature or above the plastic deformation temperature. After each blow you have to you will get a certain amount of deformation, and we have to uh, change the location of the workpiece from as many cavities are there, each time you have to change the workpiece from one location to another location so that you will get a deformation. This is the sequence followed in the manufacturing of connecting rod. This also we have seen video also we have seen based on this. Here you can see this is the flow chart. This is the material cutting to length. After cutting to length, billet is heated. After heating, hot forging is carried out. Piercing is carried out. Short blasting or pinning it is required to increase the hardness. And last is the machining. After machining, you will get required accuracy and surface finish to the forged component. In some cases, performing operation for connecting rod forging, which serve to distribute the material before actual forging, can be carried out also by reduced rolling or the cross rolling operation. We have seen in the video the grooved rollers are required, and initial shape before forging, initial shape to that component is given by the rolling, and mostly we are using a grooved rolling. In order to improve forging productivity, two at a time forging version is also developed. Means at a time two spanners. Video we have seen which is based on the manufacturing of two spanners at a time. Likewise, two connecting rods we can manufacture. Forging step for two version of such a technology is presented in figure. As it is seen in the first case, cap parts have to be forged separately. Smaller size connecting rods are preferably forged in two at a time version. If the size of the connecting rod or any kind of forged product is small, then we can go for two at a time version, and if larger size is there, one at a time version we can use to manufacture that particular product. Now we will see view 1. View 2 also we will see. Here the forging part ends We will see extrusion in the next lecture.